Okay, Assalamualaikum warahmatullahi wabarakatuh. First of all, let me introduce myself. My name is Nadine Ayasha, and today I want to explain about my paper presentation with the title The Impact of Vertical Velocity Parameter Conditions and its Relationship with Another Weather Parameters in the Hail Event. We are moving forward to introduction. Hail happened in Sukabumi, Sekadau, and Bogor on August 23, August 22, and September 23, 2020, respectively in dry season. Hail occur when strong updraft going through the air with a vertical motion. This is because of the vertical velocity or upward vertical velocity, which increase the convective cloud development and cause a bad weather. A negative vertical velocity value means that there is an updraft or upward air movement. The research about vertical velocity impact had been done by Lee and Gorman, Morrison, Peters, and Peter et al. Therefore, this study will examine the impact of vertical velocity on the hail events and its relationship with other weather parameters such as relative humidity, streamline, and wind speed. The data that used on this research are ERA5 hourly analysis data from Climate Copernicus and then high-resolution cloud analysis as a supporting data. The research method is ERA5 data that extracted to obtain the graph, contour, and Hofmüller diagram of the vertical velocity, and then UNV component are used to form the streamline and wave velocity. Moreover, relative humidity is analyzed by Hofmüller diagram. Next is the results and discussion of vertical velocity analysis in Sukabumi. The hail occurred in Sukabumi started at 8:45 UTC and lasted for 30 minutes. Based on the results from the vertical velocity graphs, it shows that the values began to decrease in all layers at 7:30 UTC, especially at 850 until 700 millibar layers. And then the value are more decreased at 8 UTC. This is supported by the results of the Hofmüller diagram, where the results are negative. In addition, vertical velocity contour has a negative value in almost all layers. Therefore, strong updraft occurred at almost all layers, especially at 850 until 700 millibar layers. Low negative values on the graph, Hofmüller diagram, and contour before the hail event at 7 until 8:30 UTC indicate that there is a strong updraft or upward vertical velocity occurred, which increase the amount of the convective clouds and trigger bad weather. Next, in Sekadau, the hail phenomenon in Sekadau occurred at 14:23 until 15 UTC. Generally, before the hail event, the vertical velocity graph shows that there is a negative value in all layers, and then the lowest value for all layers occurred at 8 UTC, especially at 850 millibar layers. And then it is indicated that there is an upward vertical velocity in all atmosphere layers. Before the hail occurred, the Hofmüller diagram still show negative values at 13 until 14 UTC. And then this is indicated that strong updraft disturbs the atmospheric conditions since afternoon and lasts until evening when the hail occurs. This hail phenomenon can occur due to fluctuation of air temperature that triggers air heating. Because the updraft is already strong from afternoon, thus supporting the occurrence of upward vertical velocity. We are moving forward to Bogor area. At 10:15 UTC, hail fell in Bogor. In general, vertical velocity graph shows that its value fluctuates at 8 until 11 UTC for all layers in the atmosphere. The lowest vertical velocity value occurred at 9 UTC. This indicated that there is a strong increase in air mass into the atmosphere and supports the convective cloud growth that caused hail. And then at 9:30 until 10:30 UTC, there is an increase in the value for all layers and shows that there is a downward vertical velocity occurred, which is indicated by hail falling at 10:15 UTC. This is supported by a Hofmüller diagram and the vertical velocity contour at 9 UTC, where the values ranges from minus 0.8 until minus 0.2 meter per second. Based on the analysis above, a negative vertical velocity value indicates that there is an updraft or upward vertical velocity or upward air movement in the atmosphere. Next is relative humidity analysis. In general, based on the Hofmüller diagram for relative humidity in the three areas, the relative humidity ranges from 80 until 95% for 925 until 700 millibar layers. The cloud which produce hail can occur due to the rising water vapor to the atmosphere, where water vapor increase the air humidity. The ascent of the water vapor is supported by the large scale of vertical velocity and then push condensed water vapor to the atmosphere, and then it makes the relative humidity wetter. Okay, next is wind pattern. Based on the streamline and wind velocity results of the 925 millibars or 3,000 feet layer in Sukabumi, Sekadau, and Bogor, there is a wind speed deceleration that forms convergence and shear line with a speed of 2 until 4 knots. This convergence is the cause of the convective clouds formation that cause hail, because the concentrated air mass supports the convective cloud growth. And furthermore, if it is associated with wind, vertical velocity has an influence and an impact on wind speed. Now, last is HCAI data analysis. In Sukabumi, the growth of convective cloud started at 7 UTC. In Sekadau, the growth of cumulonimbus cloud began since 12 UTC until 14 UTC, and then in Bogor is detected at 8 UTC and clearly visible at 10 UTC. Hail is produced by a strong updraft in the atmosphere and then forms convective clouds, especially cumulonimbus clouds. And then next, we are arrived to the conclusion. Generally, based on the results of graphs, contours, and Hofmüller vertical cut from Era 5 modeling, the vertical velocity values in 925 millibars until 300 millibars layers in Sukabumi, Sekadau, and Bogor before the hail event range between minus 1.2 until minus 0.2 for Sukabumi, and then minus 1.5 until minus 0.2 for Sekadau, and then minus 1 until 0 meter per second for Bogor. And then the second is negative value indicates that an upward motion of the air mass that trigger the convective cloud growth which produce hail, and this is evidenced by the presence of the cumulonimbus cloud on HCAI product when hail falls. Third is the relative humidity in 850 until 700 millibar layers is quite wet, which ranges from 80 until 95%. And then the fourth is the streamline and wind velocity in the three regions shows that there is a convergence with a wind velocity deceleration. And then the last is the upward motion of the vertical velocity is enough to form the wet atmospheric humidity and form a convergence for the convective cloud which produce hail in dry season. Okay, thank you very much for your attention. That's all from me. Assalamualaikum warahmatullahi wabarakatuh.